The basics of LEDs. Concept of LED bulbs and diode. Technically, LED bulbs aren't bulbs. LED stands for light emitting diode. They are tiny semiconductors, that is diodes, wrapped in plastic to protect the elements and focus the light. In electronics, a diode is a component that restricts the direction of movement of charge carriers. Essentially, it allows an electric current to flow in one direction. Thus, a diode is a semiconductor device with two terminals, typically allowing the flow of current in one direction only. The current comes to an anode that is positive and flows out of a cathode negative. LEDs do not have wire filaments, which we find in conventional incandescent lamps. Difference between LED and incandescent bulb. When we talk about a regular light bulb, we mean an incandescent bulb. Such bulbs were invented by Thomas Alva Edison in 1879. These bulbs have filaments that glow, producing both heat and light when energy flows through them. LEDs, or light emitting diode, on the other hand, is a semiconductor device that emits visible light of a certain color and is fundamentally different from conventional light source such as incandescent, fluorescent, and gas discharge lamps. LEDs do not use gas or filament, has no glass bulb. LEDs do not have failure-prone moving parts. LEDs have electrons that flow to create photons, light we can see. Photons generate almost no heat. LEDs also require much less energy to create the same amount of brightness as incandescent lights and last much longer. LEDs are energy-saving devices. LEDs use much less energy than incandescent bulbs because diode light is much more efficient power-wise than filament light. LED bulbs use 75% less energy than incandescent lighting. At low power levels, the difference is even larger. Bright LED flood lamps use only 11 to 12 watts while creating a light output comparable to a 50 watt incandescent bulb. Concept of CFL bulbs. CFL bulbs are also more efficient than incandescent bulbs because of how they produce light. According to Energy Star, in a CFL, an electric current is driven through a tube containing argon and a small amount of mercury vapor. This generates invisible ultraviolet light that excites a fluorescent coating called phosphor or the inside of the tube, which then emits visible light. CFLs, as the bulbs that are dim at first and then take a while to warm up to full brightness. Once the electricity starts moving inside them, however, these bulbs use about 70% less energy than incandescent bulbs. CFL bulbs are not quite as efficient as LEDs and they have a shorter lifespan. Popular options of lighting. There are three most popular type of lighting options: incandescent lamps or bulbs, These are typical bulbs which are not very energy efficient and they don't last long. Compact fluorescent light bulbs, that is CFLs. These are the spiral bulbs that may come to mind when we think about energy efficient bulbs. LEDs. LED bulbs are very energy efficient but still maintain the look and feel of an incandescent bulb. Incandescent, CFL and LED bulbs all require different amounts of energy, but it's LED bulbs that are the order of the day. A comparison: LED average life 25,000 hours, no mercury, 6 to 8 watts, uses 84% less energy. CFL average life 8,000 hours, mercury 13 to 15 watts, uses 75% less energy. Incandescent average life 1200 hours, no mercury, 60 watts, 90,000 energy lost to heat. A brief history of LED invention. 1962, the first red LED was developed by Nick Holonyakat, GE. Throughout the LED 60s, red LEDs were used as small indicator lights on electronic devices. Green and yellow LEDs were introduced in the early 1970s and were used in electronics, traffic signals, exit signs, and watches, etc. By 1990, LEDs of 1 lumen output were available. In 1993, Shuji Nakamura at Nissha created the first high brightness blue LED, making it possible to RGB mix to any color. This was followed in 1996 by the development of phosphor white LEDs, which combined a blue or ultraviolet LED with a phosphor coating that produced white light. 2014 Nobel Prize for Physics has been awarded to Professor Isamu Akasaki, Hiroshi Amano, and Shuji Nakamura for the invention of blue light emitting diode. By 2005, output levels of 100 lumens were possible. White light LED became available in various shades. LEDs began competing with conventional light sources and fixtures in general illumination applications. The Department of Energy expects LED technology to become the preferred method of lighting in homes and offices by 2025. Advantages of using LEDs: comparable in efficiency to CFLs, LEDs are gaining more popularity than fluorescent tubes and incandescent lamp due to their higher efficiency. Fixtures are directional, allowing for more efficient optics. Quality of white light: LEDs are now comparable to CFLs. Recent advances assure better consistency in color and CCT, that is, correlated color temperature. Significantly longer useful light output has improved by 35% per year, while cost has dropped by 20% per year. No infrared, that is IR radiation. No ultraviolet or UV rays. Mercury free. Can operate in cold environments. Can withstand impact and vibrations. Inherently digital for ease of control. instant and growing trend to modularity. Working of LEDs. Like a normal diode, the LED consists of a chip of semiconducting material impregnated or doped with impurities to create a PN, that is positive oblique negative junction. Atoms in the N-type material have extra electrons. Atoms in the P-type material have electron holes. Applying current pushes the atoms toward the junction. When they get close, the N-type atoms donate their extra electrons to the P-type atoms which accept them. A negative charge to the N side allows current to flow from the negative charge area to the positive charged area. This is called forward bias. When extra electrons in the N-type material fall into the holes in the P-type material, they release energy in the form of photons. The material in an LED is selected so that the wavelength of the photons falls within the visible portion of spectrum. Different materials produce photons at different wavelengths or color.